We are on 1.09 Algebra 2 today notes. And these notes are going to be on complex numbers. We will be graphing them. We're going to multiply and simplify. Lots of fun stuff. All right, first we're going to start with graphing complex numbers. So to do that, we have to graph them in the complex plane. So they must be graphed in a two-dimensional system, the complex plane. So it's a two-dimensional system. Just like our x and our y, how we normally graph those. So plot each on the plane and label it with its letter. Okay, so first is 5 minus 2i. So let's draw our axes over here. And there's our y-axis, and there's our x-axis. So in order to graph them, instead of our x and our x becomes our real axis, and the y-axis becomes our imaginary axis. So it's the same idea as when you plot a point, but it doesn't look like a point over here. So 5 minus 2i, that's going to correspond to the point on the xy plane of whatever your real value is. So the first number that doesn't have an I attached is a 5. That's going to be your x, since that's the real axis is your x-axis. The part with the I, that's going to be your imaginary part. So that's going to be like your y coordinate. So you're taking whatever coefficient is in front of the I. So the number in front of I is -2. So that's going to be your y coordinate. So here, if you were plotting the point 5, -2 on the xy axes, that would be the same point as 5 minus 2i on our complex plane. So we're going to go over 1, 2, 3, 4, 5, and down 1, 2. So that would be the point A. That's 5 minus 2i. Okay, let's try another one. 5i. So that would correspond to, there's no real value here. There's no number, there's no a, because these are all in a plus bi form. So there's no a part over here. So that would just be 0. And the part in front of the I, the coefficient, is just 5. So that would be the point 0, 1, 2, 3, 4, 5. And that's our B. Okay, try the next two. Pause the video and do those on your own. So figure out what point it corresponds to, and then plot it, and then check back here for the answer. All right, so this one should correspond to -4, -1, and then you would plot that, left 4, down 1. And the last one would correspond to the point -6, because that's the real part, but there's no imaginary part here, so it would just be -6, 0. So that would be left 6, and not up or down any at all. So make sure you've graphed those as well. Moving on to number 2. If the sum of 6 plus 2i and -8 minus 5i were plotted on the complex plane, in which quadrant would it fall? So first we need to know a couple things. We need to know what sum means. Sum means add. So I'm going to take 6 plus 2i and add it to -8 minus 5i. So that's really the same as saying 6 plus 2i minus plus a negative is just subtracting it. minus 5i. So look for your like terms here. And again, you should be able to do this one on your own. So even if you haven't at this point, pause, figure it out, the answer, and then check back. So 6 minus 8 gives you negative 2. 2 minus 5i gives you negative 3i. Now remember, you can check those in your calculator. The I button is second period to find I. So you would just do, right as you see it, 6 plus 2i plus negative 8 minus 5i, second period. And it gives you your answer of negative 2 minus 3i. But that's not what it asked. It asked which quadrant it would fall in. So now you're going to go to your set of axes, and you're really plotting the point negative 2, negative 3 from the A and the B. So left 2, down 3. That's going to put us in quadrant 3. Okay. All right, so moving on now to simplifying these a little bit and multiplying them. So multiplying complex numbers. So the thing you want to remember with multiplying complex numbers is this required step, which is every time you see a negative or an I squared, you're going to sub in negative 1. Negative 1 for I squared. I want you to show that substitution. So we talked about our powers of I before, and I squared is always equal to negative 1. If you forget that, again, you could check it on your calculator. So I want you to show that when we get to that point, because you can never ever leave I to any power other than 1. So simplify, answers must be in A plus BI form, and you should check on your calc, of course. Here we go. So this one, I'm actually going to start back at number 1 with my counting for these. All right, so we've got 2i times the quantity 3 minus 4i. So all we're going to do is distribute. So nothing new except that we have these i's here. So 2i times 3 is going to give me 6i. Just like with radicals, you can multiply whatever's in front of the I of the coefficient. And just like if it was a variable like x. And then 2i times negative 4i would give me negative 8i squared. So again, just like variables, x times x would give you x squared. I times I is I squared. But you're never allowed to leave I to any power other than 1. So I squared, we know, is equal to negative 1. So you're just going to show your substitution of putting in a negative 1 here. So now I have negative 8 times negative 1 is really positive 8. Next issue is that it's not an A plus BI form. We have to have the I come second, so we just use commutative property to switch it up, and we get 8 plus 6i. This can be checked right into your calculator. All you're going to do is type in 2i, and then your parentheses, 3 minus 4i, and it literally gives you the answer in A plus BI form. So no reason to be getting these wrong, because you can check them. Can I do them completely in my calculator? No. You have to show the work in order to get credit for it, but you're using your calculator as a check. All right, this one's a binomial squared. So anytime, remember, you see the parentheses are being squared, you want to do your double bubble. Rad 3 minus 5i times rad 3 minus 5i. Really, really important there. Now we're going to FOIL it. So we've got our first. So this one, a little bit of a doozy. We've got radicals and imaginary in here. So we've got rad 3 times rad 3. When you multiply radical by itself, it gives you the number under the radical. And then next we have negative 5i times rad 3. None of those things can go together. So we just kind of smush them all next to each other. Negative 5i rad 3. Middle terms. Same thing, negative 5i rad 3. And then our last terms, and this is the one where students often lose points because they're not careful with their signs and their i's. So negative times a negative is a positive. 5 times 5 is 25. And don't forget, I times I is I squared. And a lot of people forget to square that I, so make sure you do that. Now you can combine your like terms and sub in your negative 1 in for I squared because we can only leave I to a power of 1. When we combine these two, they both have an I and they both have a rad 3, so they're like terms. So negative 5 minus 5 would give me negative 10I rad 3. Just add the coefficients. And then 25 times I squared is negative 1. So now I have 3 minus 10i rad 3. 25 times negative 1 is negative 25. Combine my like terms here, and I'll get, and I'm going to make sure I write this first because I want it in a plus bi form. So negative 22 minus 10i rad 3. And I cannot combine those any further. Now to check this in your calculator, you're going to type in the original right here. And then you're going to get something that looks a little bit funky. So, because it'll have this long decimal in it and the I. So then you're just going to type in this as well and make sure it matches up with that answer. So you type in the original and then you type in the answer. Pause right now and check that. Okay, moving along here, I want you to multiply. We talked briefly about this in one of our other notes. A plus bi and its conjugate. This word conjugate, it's really, really important and comes up a lot on the Regents, on tests. You need to know how to find the conjugate and what that means. Okay, and then I want you to be thinking about, as you do this, what do you end up with? Describe your answer. Is it real or is it imaginary at the end? So that's what I want you to be thinking about, what's happening. Question mark in there. All right, so a plus bi times its conjugate. So remember, your conjugate means you take the same exact number, so the a and the bi, except the sign in the middle switches. Doesn't matter what the first sign is, that stays the same. It's just the sign in the middle. A minus bi. Always remember there's a question that shows up on, that's shown up on the Regents, sometimes on the midterm, and it's one that so many students miss, and it's just asking, it's a very quick question. It asks for the conjugate of a binomial. And most students, what they do is they negate both of them. They take the additive inverse instead of just negating the middle. All right, so now we found the conjugate. We want to multiply them together. So we're just going to FOIL this out. So a times a gives me a squared. A times negative bi is negative abi. Middle terms, inner, is positive abi. And then our last terms, positive times a negative. So be really careful because the last one is always the one that students mess up. So take your time, make sure you get the signs right, make sure you get everything squared that needs to be. Positive times a negative is a negative. B times b is b squared, and I times I is I squared. A lot going on there, so please make sure you get all of it. All right, so now we've got the inside terms here cancel. I have a squared minus b squared, and I have to replace my I squared to negative 1 since I can only leave it with a power of 1, and that has a power of 2 on it. Okay, so now I have negative b squared order of operations. I have to do multiplication before I can do anything else, before I can do the addition. And I have negative b squared times negative 1 would give me a positive b squared. And I can't combine any like terms from here, so that's as far as I can go. So now I said I wanted you thinking about what your answer looks like. So here we no longer have an I in our answer. So this is actually a real number. It's not imaginary because there's no I left in your problem anymore. Okay, let's simplify some complex fractions. Simplify. So when we do this, what I want you to be thinking about is that you can't leave I in the denominator. Just like we don't want a radical in the denominator, we don't want an I in the denominator. So whenever you see an I in the denominator, we have to get rid of it. Also note that most of these can be checked in your calculator as well. So check in calc as well. Okay, sometimes it will be hard to check it in your calculator, but most of the time you can. So number 4, 5 over 3i. So pretty basic here. We just have a fraction. The only issue, it's all reduced. The only issue is that there's this I in the denominator. So just like with radicals, to get rid of a radical, we'd multiply the radical by itself because a radical times itself gives us the number under the radical. When we want to get rid of an I, we just multiply it by itself as well because we know I times I gives me I squared. And I squared, as we've done a lot today, is equal to -1. So if you have an I in the denominator, can you multiply it by 3i? So a lot of people multiply it by like -3i after we do the next step. And that's fine. It's just more work because you have to reduce it in the end. So don't forget to reduce it completely. But if there is an I and it's a monomial, there's no addition or subtraction in the denominator, you just multiply by I. So here we have 5 times I gives me 5i, and in the numerator, i's are fine. And 3i times I would give me 3i squared. And I know I squared is the same thing as -1. So now I have 5i over -3. And sometimes people don't like to leave the negative in the denominator, so you can write that right out in the front or on the top. It all means the same thing. Some people forget that. 5i over -3 is the same thing as -5 over 3, which is the same thing as -5i over 3, whether it's in the bottom, the top, or out in front. Okay, let's try another one, this time with a binomial in the denominator. So here, we now don't just have 3 times I, we have 3 minus I, and that's a lot different because if I were to do the same thing as we did on number 4 and multiply this by I, then if I distribute it, I get 3i minus I squared. So the I squared would become a -1, but you'd still have this 3i in your answer in the denominator, and we don't want an I in the denominator. So I want you to think about what we did in number 3. We multiplied a plus bi by its conjugate. And what happened? When we multiplied them together, we lost the I, and it became a real number. So that's what we want to do every time you have a binomial. You're going to multiply the bottom by, I'm going to put these in parentheses, by its conjugate, so 3 plus I. And if I do that to the denominator, I need to do that to the numerator. So now I've got this numerator here that I need to FOIL out. So 2 times 3 is 6, plus 2i, plus 3i, plus I squared. Over, in the denominator, we're going to FOIL that as well. 9 plus 3i minus 3i, and these middle terms should always cancel. And again, the last term's very, very important. Negative I times positive is a negative. I times I is I squared. All right, let's continue to simplify. So I've got 6. I can combine these two in the middle to get 5i, and my I squared, is -1. In the denominator, middle term should cancel out. I have 9 minus -1. Be careful. I'd rather when you're subtracting, you not put parentheses because that tends to confuse people. So with multiplication, put the -1 inside parentheses. If it's addition or subtraction, don't use parentheses. Here, combine your like terms. 6 minus 1 is 5. I'm going to write it first so that it's in a plus bi form. And 9 plus 1 is 10. Now we still have another issue. You're not allowed to leave it like this because we want the answer in a plus bi form, so you have to separate them. If it's asked for it, if they ask for it in a plus bi form. So you're going to take 5 over 10 plus 5i over 10. So I just broke it up into these two and these two. And then last step is we're going to reduce. So 5 over 10 is 1/2. And another 1/2. I didn't write the 1. You can write 1 over 2i is the same thing. But remember, if you have 1 over 2 times I, that's the same thing as I over 2, which is the same thing as 1i over 2. If it's next to the I, it means the I is in the numerator. So that's just a little side note. This would be your answer. And again, to check these, all you're doing is typing in the original problem into your calculator. And a lot of times it'll just fix it for you when you hit enter. So like you'll just hit 5 over 3i and it'll give you your negative 5 over 3. So do your alpha y equals. And so I'm going back to number 4 and just checking that one, and then I'll let you guys check the other. Hit enter, and there's your negative 5/3 I. Again, same thing as we wrote the I in the numerator. It's the same thing when it's next to the I. So some of them will look a little bit funky when you check them. So this one will be a little bit different, number 5, but just type in the answer and see if you get the same thing is what usually is helpful if you get something a little funky. All right, a little quick review of inverses. So additive inverse, if you're taking the additive inverse of something, then you're taking the opposite of it, meaning the opposite sign. So when you add additive inverses, you get 0. That's your additive identity is 0. Okay, if you want to take the multiplicative inverse, then you're taking the reciprocal. And when you multiply multiplicative inverses, you get 1, which is your multiplicative identity. All right, so number 6, find the additive inverse of 6 plus I. So if I want to figure out what the opposite signs are, or what could I add to 6 plus I to get 0, I'm just going to negate every term. So I would negate the 6 is positive, it becomes negative. The I is positive, it becomes negative. So that would be your additive inverse of 6 plus I. Find the multiplicative inverse of 3 plus I. Okay, so for 3 plus I, to find the multiplicative inverse, we multiply by its reciprocal. So actually, let me just take a step back here and review what those are with plain integers. So if I wanted to find the additive inverse of 2, the additive inverse would be negative 2, because 2 minus 2 gives you 0, which is your additive identity. So you're just changing the sign. If it was negative 5, the additive inverse of that would be 5. Add them together, you get 0. If you are doing multiplication, let's say I have 3 over 2. The multiplicative inverse would be 2 over 3, because if I multiply those together, those cancel, and I'd get 1. 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1. If I had 1/3 times what would give me 1? Well, again, you just take the reciprocal, you flip it. 3 over 3 is 1. And if you had negative 5, so that's negative 5 over 1 times what would give you 1? Again, you just want to take the reciprocal. So negative 5 in the bottom, 1 in the top. You do want to keep the negative, though, because you want them to multiply to a positive 1. And a negative times a negative is a positive. So now back to our imaginary ones. If we want to take the multiplicative inverse of 3 plus I, that's really 3 plus I over 1. I'm just going to take the reciprocal. So flip the entire thing. So 1 over 3 plus I. Uh-oh. Now I have an I in the denominator, and I can't have that. So I asked myself, is it a monomial or a binomial? And it's a binomial. So we're going to do like we did in number 5. We need to multiply by the conjugate. So let's multiply by 3 minus I. So the signs stay the same, you just change the one in the middle. So the top, that one a little easier on this one, you just have 3 minus I times 1 is 3 minus I. The denominator we need to FOIL. So 3 times 3 is 9 minus 3I plus 3I. Positive times a negative is a negative. Again, slow down on this last one. And I times I is I squared. Let's simplify. 3 minus I over, middle terms cancel. I have 9 minus I squared is negative 1. I'm adding or subtracting, so no parentheses. Change it to addition, and we get 3 minus I over 10. And we're not allowed to leave it like that because it's not an A plus BI form. So I need to separate it. So I get 3 over 10 minus I over 10. So I just put the 10 with each one. And that would be your multiplicative inverse in A plus BI form. Last one, let's do another multiplicative inverse. Pretty short one though. Inverse of 1 over 6I. So if you want to find the multiplicative inverse, we want to know what multiplies times 1 over 6I to give you 1. So you take the reciprocal. So additive inverse, think negate, multiplicative inverse, reciprocal. So the reciprocal of this would just be 6I. And no issues there because I don't have a fraction. So there's no concern about an I being in the denominator. Okay, that is it for our notes today. If you have any questions at all, please let me know. Make sure you're staying on top of these and that you're understanding them and doing the practice problems completely on your own, checking them with the answers and letting me know if you have any questions at all. Don't let this creep up on you like some of you did with the first couple lessons. So again, see me if you have any questions at all. And I hope this all makes sense. And I hope to see you soon. Pie out.